Hello friends, welcome to Susan and John MathTube. In this video series, we will go through one old question paper, that is the exam which was supposed to be from 2076 Chaitra, but it was conducted very recently, 2077. Anyway, let's go for the first question. So look at this. The story is about, and one very important thing, in statistics you will meet a lot of word problems, and if you want to solve the word problems successfully, I will strongly recommend you read the question at least 3 times. When you read the first time, it's kind of like reading a newspaper. You'll see many things, but it doesn't get inside your brain. And when you read it the second time, you'll be able to see many things which you missed in the first time. And you read once more, you'll be able to collect all the data. Okay, and another important thing, in the statistics exam, if you look at the past year question papers, they ask a lot of theory questions. So please make sure you're very good in theory. And if you write your own theory, don't expect you'll get marks. But if you understand the concepts and if you answer in your own words, that's okay. Anyway, let's go through the question. So they are talking about a professor of statistics, and he's so worried about his students. He's collecting data about how much time the students are using their mobile phones, or let's say they are spending time on social media during the college hours. Okay, so he collected data from 20 students. So I'm going to write n is equal to 20. And finally, the conclusion is he found that the average, the arithmetic mean, is 20 minutes. That is, he found that in an average, a student will spend 20 minutes in front of some social media website. And there is a plus or minus, so he found the standard deviation to be 5. But something went wrong. Later, when he checked the data, when he was going through the data, he found that the observation 30 was entered as 13. So the data which is supposed to be 30, he entered 13. So now we can understand the question. We have to remove the wrong data and we have to plug in the new data. So they are asking, find the corrected mean and the corrected standard deviation of time spent by blah blah blah, etc. Okay, so this is very easy. I am 99% sure that all of you know the formula for average, arithmetic mean. So look at this, the average is given to be 20 and the standard deviation is given to be 5. Anyway, let's solve this side first. Average is given by sum of all the data, which I am going to call it x, the whole divided by n, and that is equal to 20. Now look at this, the professor interviewed 20 students, and that means n is equal to 20, and that gives me sigma x equal to 20 times 20. That is the wrong sum. I'm going to write here, this is wrong because he put some wrong data, is equal to 400. Therefore, the corrected sum will be, I'll write CURR only. So the corrected sum will be 400. Look at this, I'm supposed to get rid of 13 and plug in 30. So I'm going to add 30 and subtract 13. And that means the corrected sum will be equal to 417. And that gives me the corrected arithmetic mean. What's the formula for arithmetic mean? sum divided by n. N doesn't change because we kicked out the wrong entry and we plugged in the correct value. So that gives me 20.85. So I am going to write the corrected arithmetic mean is equal to 20.85. Okay, now the second thing, standard deviation. So look at this, the wrongly calculated standard deviation is 5. I hope you remember the formula for standard deviation, root under sigma x squared by n minus mean squared, that is equal to 5. So look at this, when he plugged in the wrong values, he got 5. And that means I have to plug in the wrong values. That means n is equal to 20 and the arithmetic mean means the original. Original in the sense the wrong one, the value that he calculated. So that will be like 20 squared is equal to 5. Squaring on both sides, we get sigma x squared by 20 is equal to, this is 400 and it goes to the other side 425, because when we square this 5 becomes 25. So sigma x square means we are squaring each and every data and adding them. I'll repeat, sigma x square means sum of the squares of the data. Okay, and that will be 425 into 20. So this is the wrong summation of x squared. Once more I'll tell you, the wrong entry is 13. So I'm supposed to get rid of 13 squared. And the correct entry is 30. So I'm going to add 30 square. The corrected summation will be 9231. You can calculate. Okay. So the corrected standard deviation will be root under, we plug in the new values. 9231 divided by 20 minus the corrected arithmetic mean. Okay, you can calculate it. Anyway, I got the value 5.18. Okay, now let's move on to the next question. Look, I told you it's a 6-mark question and they always tend to ask theory questions. It can be any basic definition. It can be the statement of Bayes' theorem. So in this question they are asking, what do you mean by mutually exclusive events? So look at this, mutually exclusive events means events which cannot happen simultaneously. I'll give you an example. Suppose you're tossing a coin exactly once. And let's say the possible cases are getting a head or getting a tail. Now look at this. In case you get a head, that means you're never going to see tail again. In case you get a tail, that means you're never going to get a head again. So when you toss a coin exactly once, head and tail becomes mutually exclusive. I'll give you one more example. Let's imagine you're rolling a dice. So the outcomes will be 1 or 2 or 3 or 5 or 6. Now let's say A be the event of getting odd numbers and B be the event of getting even number. Now look at this, you're rolling a die exactly once. Now if you get an odd number, that means this cannot happen. And if your outcome is an even number, that means the other one cannot happen. So whenever 2 or 3 or 4, let there be any number of events, if one event prevents the happening of others, look at this, A can happen, B can happen, C can happen, D can happen. But if A happens, the other events cannot happen, or the simultaneous occurrence of events is not possible. And such events are called mutually exclusive events. Okay, now the second one, independent events. Independent event means events which do not depend on each other. Events which do not depend on each other. The best example will be you and your friend writing the same exam in two different colleges or two different buildings. So look at this, you are going to answer the same question paper. Both of you will be given the same time. Everything will be same. But you are not asking your friend for help. You and your friend are going to solve the question paper independently. So events which do not depend on each other will be called independent events. And the last thing to write in examination is the conditions. Let's say A and B are mutually exclusive events. What do you mean by mutually exclusive? If A happens, B cannot happen, and if B happens, A cannot happen. And for mutually exclusive events, union will be the sum of the probabilities. So probability of A union B will be probability of A plus probability of B. And suppose there are like three events A, B, C, then probability of A union B union C will be probability of A plus probability of B plus probability of C. Now suppose A and B are independent events. In the case of independent events, intersection will be equal to product of probabilities. So that's it. You can collect more data from any book you like, or you can just search online, get a clear idea about these concepts and write in your own words. But never create your own theory, but understand it properly and write it in your own words. Okay, now let's go for the main part. An insurance company insured 2,000 civil engineers, 4,000 electrical engineers, 6,000 mechanical engineers. Okay, this is Bayes' theorem. I'm 99% sure. The probability of an accident involving civil engineer blah 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 is given. One of the insured engineers met with an accident. Okay, in our class we learned about Bayes' theorem. So let it be any Bayes' theorem problem, you should first identify the mutually exclusive and exhaustive. Exhaustive means the events whose union will be the sample space. So look at this. If you look at any insured person, according to this question, it will be a civil engineer or an electrical engineer or a mechanical engineer. So such events will be called E1, E2, E3. So E1 means the insured person is civil engineer, and E2 means the insured person is electrical engineer, and E3 means the insured person is a mechanical engineer. A means, look at this, in all Bayes' theorem questions, something will happen. Okay, in this question it is given one insured engineer meets with an accident. Okay, and that will be A. So you can write insured person met with an accident. Now remember, in Bayes' theorem you can calculate only E1 given A or E2 given A or E3 given A. Never forget, in Bayes' theorem, if you define the events to be E1, E2, E3, etc., etc., the only thing which you can calculate is either E1 given A or E2 given A or E3 given A. Now let's look at the question and understand. The required probability is probability of E1 given A. Look at this. E1 means the insured person is a civil engineer, given that the insured engineer met with an accident. Okay, so since I called E1 to be the event regarding civil engineer, the required probability is E1 given A. Okay, so this will be probability of E1 multiplied by A given E1. The whole divided by probability of E1, probability of A given E1 plus probability of E2, probability of A given E2 plus probability of E3, probability of A given E3. Now look at this. Probability of E1 means what is the probability the insured person is a civil engineer. Now look at this. It is given that there are 2000 civil engineers who are insured and 4000 electrical engineers and 6000 mechanical engineers. So mechanical, electrical, civil. So probability, now look at this, probability means favorable case by total. So total is 6 plus 4, 10, 10 plus 4, so 12,000 engineers are in total. So probability of E1 will be equal to 2000 divided by 12,000 multiplied by, now look at this, this is very important, probability of A given E1. Look at this, when we find conditional probability, you should remember the quantity after the slash is a condition, it's a guarantee, and we have to find the probability of the quantity before the slash. So what is the probability the insured person met with an accident? Guaranteed, I'll color it in red for you, guaranteed he is a civil engineer. What is the probability the insured person met with an accident? And the guarantee is it is a civil engineer. Now if you look at the question, you can see that the probability of a civil engineer getting involved in an accident is 0.01. So that will be 0.01. The whole divided by, copy the same thing, 2000 divided by 12,000 multiplied by 0.01 plus probability of E2 means similarly. Now I am not repeating the story. You can get it 4000 by 12,000 multiplied by 0.03 plus 6000 by 12,000 multiplied by 0.15. Okay, you can use the calculator and simplify. I got 1 by 52. It's approximately 0.019. Okay, that's it. Now let's go for the third question. Okay, 5 marks theory question. So look at this. Theory is very important. Even in the last question, which was a numerical, you saw that they started with a theory question. Again, question number 3, it's a pure theory question. And the question is very simple. What are the characteristics of binomial distribution? Now look at this. You have to study 4 distributions which is discrete and 3 distributions which is continuous. In your syllabus, you have binomial distribution, Poisson distribution, hypergeometric distribution, negative binomial distribution, and 1, 2, 3, 4. These 4 distributions are discrete. And the continuous distributions are normal distribution, gamma distribution, and chi-squared distribution. I checked so many question papers. In most of the question papers, they ask what is chi-squared distribution. They just ask the distribution. You can look at the handbook that I provided, and you'll get the definition of chi-squared distribution. Or you can search online what is chi-squared distribution, you'll get the definition. And the problems normally come from normal and gamma. Anyway, you should be very good with the theory part. And remember, binomial problems can be approximated into normal. Poisson problems can be approximated into normal. And binomial problems can be approximated into Poisson. So look at this. Binomial and Poisson problems can be approximated into normal. And binomial problem can be approximated into Poisson. So now and then they ask the approximated version, the conditions for approximation, etc. etc. So be prepared for that. So I'll repeat once more. A very repetitive theory part is how to approximate or when to approximate, or the conditions that we can approximate binomial problems into Poisson. Or they may even ask when can we approximate binomial and Poisson into normal. So be prepared with that. And they can ask questions like this: just define binomial, just define Poisson, define hypergeometric negative binomial. And when they ask questions like that, you can talk about the conditions, and you can talk about the distribution, its mean, its variance. And remember, the main focus should be condition, when to apply, how to identify a binomial problem, how to identify a normal problem. That part should be clearly written. It's not like what you call, if you write pages and pages, that they will give you a mark. The point, you have to write point by point. Each and every point should be clear. Okay, anyway, let's jump to the question. What are the characteristics of binomial distribution? Look at this. Whenever they ask binomial distribution, first of all, you should talk about the Bernoulli trial. Because binomial distribution does not exist without the existence of Bernoulli trial. Now look at this. Bernoulli trial means an experiment which will have only two possible outcomes. And the outcomes will be complementing each other. That means if this happens, this will not happen. And if this happens, then this cannot happen. And they are called, kind of like a pet name, they are called success and failure. Don't compare the success of the things which in your real life, because in real life, imagine you go to a shop and you buy something. Will you call it a success if you get some defective items? No, no way. This is simply called success and failure, kind of like the labels. Basically, they are complementary events, and the probability of success is P if this is the success event, and the probability of failure is 1 minus P, which we call Q. So remember, the sum of the probabilities P and Q will be 1. So such an event is called Bernoulli trial. Now imagine we conduct this Bernoulli trial again and again and again independently. Okay, one of the best examples that you can understand is tossing a coin. When you toss a coin exactly once, there are two possibilities, head or tail. And the probabilities are clearly defined 1 by 2, 1 minus 1 by 2, 1 by 2. Now imagine you toss the coin again and again and again and again, let's say n independent times, or rather n independent trials. That's it. Now the Bernoulli trial became a binomial distribution. Now look at this. Now what we do is we calculate the probability. We are trying this, we are doing this experiment n number of times. Now I am going to write the probability of x number of success. For example, let's say we are tossing the coin 10 times. And my question is, what is the probability of getting 3 heads or 5 heads or 9 heads? Generally we call it x. And it is given by ncx, p to the power x, q to the power n minus x. It's a very simple logic. Okay. And the mean is given by n into p, and the variance is given by n into p into q. That's very important, independent trial. Okay, now how does it differ from hypergeometric distribution? Okay, let me explain the scenario. Hypergeometric distribution is somewhat similar. Okay, let's say there are capital N number of items. And I know that out of this n items, A items are something like special. That means capital N minus A items are not that special. Now what we do is, we select a sample of n items. My question is, what is the probability of getting x number of special items? So look at this. Basically we have n items and I am selecting n from here. And out of this n items, A are special, and I want the probability x will be special. That means n minus x unwanted quantities are there. And its distribution is given by NCN, that's the total possibility, and ACX for here, and n minus C, n minus x. And you can define the mean, you can define the variance. Now, the most important thing, in hypergeometric distribution, the probability can keep on changing. In binomial distribution, the probability is fixed. We are doing the trials again and again and again independently. But here the word independent is not mentioned. So that's the basic difference between hypergeometric and binomial. Okay, so you can read more about it, prepare notes, and be ready for the theory questions. Okay, so I'll end this video here. I'll be back with the remaining questions in the next video. So till then,